Hey everyone, welcome back to my daily coding series. Today's day 74. Sorry about the audio today. Um, so I'm just going to do another problem, kind of somewhat randomly. I've been really busy recently, so I'll probably just do an easy number so I can get back to my homework. Um, let's try. We could do a tree problem. We can. No, I don't want to do these. We could try this one. Backtracking. Okay, so this is sum of all subset XOR totals. So the XOR total of an array is defined as the bitwise XOR of all of its elements, or 0 if the array is empty. Okay. So we're given an array, and we must do the XOR totals of every subset, and then return the sum of that. Okay. So first let me make a function called XOR total, which will take in a list. Yeah, so from a design perspective, I'm thinking like generate all subsets, and then for every subset, solve XOR total and add to results. So we'd have something like this would return XOR total of a subset. So let's say that takes in a subset. And then we'd have something like say generate subsets, and then maybe this would, for instance, say it would call, so we'd have a result variable, and then we would result plus equals XOR total of subset, for instance, and this would generate all subsets and call that, and then we would return. So from a design perspective, I think we could do something like that. So let's look at some examples. So the first example is nums of 1 and 3. So it has 4 subsets. So all the subsets are nothing, just 1, just 3, and then 1 and 3. So it's 0 plus, so we would just call the function on each one of these, and it would be 0 plus 1 plus 3 plus 1 XOR 3, which is 2, according to this. So in Python, to do XOR, you just do 3. So you'd say 1, and then this operator is XOR. So if I were to print 1 XOR 3, that should print out 2. And yeah, so this should print out 2. And the reason is if you represent these numbers, yep, so 2. So if you represent these numbers in binary, so 1 is 0, 0, 1, and 3 is 0, 1, 1. And then if you XOR that, you get 0, 1, 0, which is 2. So that's the XOR operator. Okay. So then we would sum these together. 0 plus 1 plus 3 plus 2 equals 6. So let's look at example 2 here. So if nums equals 5, 1, and 6, then the subsets equals just 5, just 1, just 6, 5, 1, 5, 6. So it doesn't have to be contiguous, like you can skip with subsets. So, and then 1, 6, and then 5, 1, 6. So these are all the subsets. Yeah, so that's kind of the approach, and then all of these are pretty straightforward. So you just kind of have like a, for this function, for instance, you would have like a total, and then you would just say, uh, you know, for num in subset, total equals total XOR num, and then we would just return total. Yeah. So that would solve one of them. So let me remind myself on how to generate all subsets. So this is kind of the hardest part of the problem, is generating all the subsets from an array. So in this case, so the way I'm thinking about it is we at every element can choose whether to include it or not. So we would just have a decision tree of including it or not including it. So we'd have like 5, 1, 6, and that would branch off into either we include the 5, so it would be like I equals 0, and then we either include the 5 or we don't. So then we would say if we do include the 5, it would be 5, 1, 6, but now I equals 1. And if we don't include it, it would be 1, 6, I equals 1, like this. And then from each of these, there's another branch, so now we can either include the 1 or not. So if we do include the 1, then it would be 5, 1, 6, I equals 2. And if we don't include the 1, then it would be 5, 6, I equals 2. And now from this branch, same thing. So we can include the 1 or not, which would be just 6. Right, okay. So for generate subsets, so we will probably and the way to do that is probably each of these should be its own list. So we can just start it with an empty list. So we'll call generate subsets with an empty list and I equals 0. So then we'll just say current and I. So we know for sure we want to stop when I equals the length of nums. Whoops, I think I just muted myself. Hopefully I haven't been muted for a long time. So if we have 4, 5, 6, and we want to skip 1, so we'd go up until 1 not inclusive, which is 4, plus, and that this is like concatenate. So concatenated with 2 onward, so that'd be 6, so it'd be just 4, 6. And when it comes to edge cases, so let's say I was equal to length minus 1. So if I was 2, then it would be up until 2, and then 3 onward. And I think that the way... yeah, so this might cause an issue, because if I have, let's say, a list which is 4, 5, and 6, and I want to print out a list from 2 onward. So this would be fine, but I think if I do this, this would give me an error. So let's, I don't think I have any other syntax errors, hopefully. So I think that would give me an error. Okay, no, it doesn't. So with Python splicing, it doesn't, it's actually impossible to give you an out of bounds error. I wasn't exactly sure, but now I remember. Okay, so in this case, we're going to generate subsets, one with the current and one without it. And then, okay, so once we are at our capacity, we want to call XOR total with current. I don't think we have to copy it because we're not modifying it and we don't really need to save it. These we should copy though. This will create a new list, and this will create a copy of the list, because I don't want it to be, well, maybe, okay, I don't want to over optimize, so let's just try it like this for now, and then maybe I can play around with it later. So we'll say result plus equals total of current. Okay, I'm going to try running this, and we also have to return out of here as well. Okay, so I'm going to try running that and see what problems I run into. So result is not assigned to a value. Yeah, that's because here so I could pass result as well, I suppose, because here we are assigning a local variable. Yeah, okay, I'll pass result as a value as well. So maybe I don't need this line right there. So I think that would work. Actually, that might not work at all, now I think about it. I'll see. I'm not sure if this will work, because each call would have a different cannot access. Yeah, this doesn't work. Okay, before I over optimize, so I'm gonna just do this, because I'm trying to over optimize too quickly. So if I just do a non-local variable here, then it should recognize this as the variable in global scope. So I'm gonna run that. Okay, so our output is always 0. Okay. is that? I wonder if it's just returning this one. Let me see, calling generate subsets with current equals and I equals, like that. Okay. So I'm thinking that, so current is always empty. Is it because I'm never adding? Yeah, that makes sense. So, okay. So I'm writing this function as if I'm sending nums as current, but I have an empty list. So I think it may work if I do nums. I'll try that. So my output now is 9. This was correct. This was not. Okay, so let me see here. Called XOR total with current, and I can print what result equals as well. So I'm just kind of print debugging here. Okay, so I'm calling it several times. So that, okay, I want to pass in a copy of nums. Could that be why? Because it was shrinking every time I did this, it was adjusting the length of nums. Okay, so this one, alright, so it's calling it with 1, 3, with 1, with 3, but then with 3 again. So I think this part is incorrect. So, yeah, what happened was I kind of just made this one going from full list to an empty list, but I initialized an empty list. So, yeah, so how do I want to, is it possible I could also just, yeah, I think a better way to do it would probably be something like current.append nums of I, call a function, and then current.pop, and then call a function. Because we're going to add it, call the function, add it, call the function, add it, call the function, pop it, call the function. So this will give us, yeah, so I'll try this. Because basically at every point we're calling it with nums of I and without. So we'll put in an empty list again, like how I initially had it, and then I will say current.append nums of I, and then we'll call generate subsets with current I plus 1, and then current.pop, and then generate subsets current I plus 1. Okay, so this will, alright, let me try that and see if that works. Okay, so that seemed to fix our backtracking error there. Okay, let me see if that passes the test cases. What are the parameters? 1, 2, Okay. So it looks like it passes, it's very slow, and we're also using, so now we could focus on optimizing it more, now that we have the basic idea. So the non-local res, I don't know if there's a better way to do this than just having a global variable that keeps track of it. We could have, so this could return, could we just make this return this value? And then so if we had, so I'm gonna try to think of a, basically what I'm doing now is I'm gonna try to think of a better way to do this, and replace the local variable, or sorry, the global variable. Um, yeah, so we have currents, which is just O of n space. So we could have, so generate subsets should return the result. So if we have one subset, let's say of 4, 5, 6, and I equals 1. So this should return, so we're not done yet. So it should just return generate subsets of skipping it plus not skipping it, right? So generate subsets of both of them. So if we summed both of these together, so it would give us, like, if we skipped one, it would give us 4, 6 plus 4, 5, 6. And what would call this? So this would be, so if we start generate subsets of, well, yeah, but we're actually given a, it's not exactly how we're doing it because we're starting from an empty list. Okay, so what if I said, so this is how we start. So what if I said that this was equal to, so this returned the value of generate subsets of 4, I equals 1. I might not even need I now that I think about it because we can just check if length of current equals length of nums. Yeah, so I'll get rid of that. So if length of currents equals length, well, not necessarily, no, that's not true either. Because we could have, a subset of just one, like of length 1, and that's still a valid subset, and we still want to stop. Okay, so if we keep the i's, so what if this returned this plus generate subsets of nothing, I equals 1. So this to me kind of seems like the right idea. And then eventually you just get to your base case, which would return this. So I'll try this out. So we'd have like, so this function would return, so how can I return this plus this? I mean, I could say something like this, I guess. And then that would return a plus b. So we would have to calculate this first. So this is so I wonder if something like this would work, and then we wouldn't need these. Okay, I'm not muted. We wouldn't need these functions, and then we can just return the first call like that. Let me see if that gives me an error. Okay, I'll try submitting this. Okay, nice. So this is much better than using the global variable. Okay. Is there any other optimizations I can make? I could just put this part inside the function. Or maybe there's some, I don't know, is there some like trick with the XOR that we can know of? I'm not sure. I could maybe turn this into list comprehension. I could say that total equals well, I want to fold it here, so I'm folding it. So if you wanted to get like the sum of a list, you would say sum equals 1 for I in num. Well, then you would have to sum it together. Yeah, how would I do list comprehension here? Probably say total plus, I guess it would be XOR equals num for num. Something like this. But we don't need the list, we just need the value, so I don't know if this is really a good use case for list comprehension. Because I could replace this for loop with this, but then it just, we're not using the list at all. Yeah, there's actually no list here at all now that I'm thinking about it, so list comprehension wouldn't really make sense. Yeah, I'm kind of happy with this, to be honest, so I'm glad that the biggest thing for me was not using the global variable and kind of thinking recursively about how we can make make this function return a value at every step instead of just incrementing a global counter. But yeah, I think this will be good for today's video. Thank you guys for watching. Today was day 74, I believe. Sorry about the audio again, but should be back to normal tomorrow. So thank you guys for watching, and goodbye.